Uh, Hello everyone, welcome to the seventh episode of uh, Live Code Retracing in Weekend book series in OCaml. So last time we partially finished the bounding value hierarchy, but the code doesn't compile as we see here. It says the BVH node module is dangling. So let's go back, see what is going on here. Inside the BVH node module, we refer to the module itself, but OCaml is really unhappy about that without using any kind of recursive modules. But we cannot make a file module, recursive module. So what we will do is to make, instead of using this BVH node file, make this file this BVH node module a nested module inside the inside the thing. So this way we can just avoid this problem. I also change it a little bit here since the number can only be 0, 1, 2, so there's no way to have an additional branch to check for. What we will do is go back to the thing. And then we explicitly have a module BVH node here, because here is the only place we actually need to use that BVH node module anyway. And we need to make this module recursive. Recursive module must have a explicit type signature, because we don't understand what it is when we do the recursion, so type inverse will not work here. BVH node is a shape, but it should also have a constructor that takes a list of shapes we have seen here and just BVH node. OCaml module syntax always confuse me. Looks good enough for me, and I don't need this file anymore. course, our BVH node is nested in the scene. When we refer to something inside the scene, we don't need to use scene dot. And we really don't need to expose bounding value hierarchies because it's internal only info for the OCaml, no, for our retracer. Now let's go back to the book because this part compile, even though we haven't really changed anything inside our code. Our things still use a list. It's basically a list of the polymorphic shape instance, and then we do hits. We just walk through all the object one by one. And what we will change is to use the bounding value hierarchies tree structure to model the scene. So next step is to implement the hit function. We first check if we hit with the outer bounding box. If we hit the outer bounding box, we just returns because there are no need to continue checking what is inside. Otherwise, we check both the left-hand side and the right-hand side. And then we will return the closer hit of those two. Notice this code here is a short circuiting optimization for the BVH node function. I will not do this optimization, at least for now, because I don't have this tmin and tmax parameter inside this code base, but that can be changed later. It takes tmin and tmax. Let's just use some dummy values. For the ABB itself, it will be the enclosing box. Returns an option of a pair. So we can use this. Oh, that is handy. Know about that. That is not in the OCaml standard library, but it is only in the base library that we use to substitute the OCaml standard library. So I will explore how to use this operator later, but now let's okay. Oh, I see how Tme and Tmax is used here. First short circuit of outer box. And I think if this is a way, it is worthwhile to have Tme and Tmax parameter and perform short circuiting. We'll do this later. Now let's just ignore those for now and first let this code compiles. If we hit the enclosing box, that means it is possible we hit what is inside this bounding box, but it's not necessary, and that's why we need to recurse. First, we need to unwrap the left-hand side and right-hand side from the module. say we do intersection test with left-hand side and right-hand side simultaneously. Later we will perform some short circuiting. That's why we still separate those two, because later they will have some interdependence. We pattern match on the tuple of the result. If both sides returns, then we need to check which side have larger t. I should say smaller t. Else, if only we have left-hand side, then it's clear we only need left-hand side. We can only return left-hand side. Similarly for the right-hand side, otherwise, if we don't have any intersection, then just nothing get returned. Wait. This function actually only returns can be potential future optimization ability. Sorry, before I said this function can be used for short circuiting. It is. We are not utilizing anything now, at least from the current code on the book. But it still returns a bool, not an option with additional information. We cannot use this fancy monad like stuff. Instead, we need to use normal if-else. We need to open float because we need to use floating point comparison here. Nothing seems to break. So the next step is to actually make our thing use the BVH node module to currently everything is just a list. We can make everything a root element of the BVH node module. However, if we do this, we can no longer just keep adding stuff to the thing like we are doing currently. Instead, we need another theme builder, kind of builder design pattern to add everything to the builder at once and then construct the thing use of the underlying BVH using the builders. Because our BVH constructor only accepts all the shapes at once, it cannot be constructed incrementally. So what we will do is to need to change this. We don't have use this add function anymore, but instead we will have a theme builder. And add shapes to the scene. No, we have add function to add. This is just add to the builder, and then we do all the construction of the thing at once. Then we add all the objects to the thing. Instance. After we add everything, we can build the actual thing. Which is a BVH node, and we add all the shapes to it. Since our builder is basically a list of shapes, I will just call it shapes inside this function. This way it returns a BVH node, but what we need is or we can just need an abstract shape. That should be good. This way we can have a builder build a scene. And don't need a create function for the scene anymore. We already deleted that. Also, this hit function needs to change. Instead of doing our naive way of just looping through all the objects and test intersections, we need to only test intersection for the root. Missing a name. Here. We don't need any of this code. We only need to deal with root. We should fix everything inside this file. Yep. Everything compiles. That not necessarily means everything is good, but I assume I don't have any problems inside this particular code. And we also need to fix stuff here. This looks very redundant with scene builder inside scene. Just call this module builder. So it's like scene builder, not scene builder. I have seen a lot of code like this. For example, in C++, we can have a namespace called graphics. Inside is a namespace called metal, and inside another class called metal device, something like this. Redundant if we already have an alternate namespace to repeat that name. The same idea here, we don't need to put scene builder because it is already inside the scene. What else it can build? Yep. Oh, we don't have a creates empty function for the builder yet. We'll deal with that soon. We haven't built the scene yet, so this scene variable actually have the build.t type. And I think we fixed everything inside the text. All those scene.builder things are a bit verbose, so and inside the main file is the same business of we need to change the whole scene function. That is the only function we need to change. I think this will do what we expected. Wow, 30 seconds. This is like 6 times improvement, about 6 times improvement over our previous version where we just naively loop through all the objects. That's the beauty of accelerating data structures. And we only have 100 objects. If we have more objects, then we surely have even bigger improvement. Save that. I think that is everything I want to say because I really haven't prepared to do anything afterward. But for next, and we will start to tackle textures. First is just it is kind of solid pattern textures, and then procedural textures like polynoise. And if we have time, we can even start to have image textures. So we will have mapped image like mapped shapes like this, and that is probably everything I can be done next week. We will not starting anything about rectangle and lights of the container box stuff until the week after next. Thank you for watching, and sorry about this short episode, because I haven't worked on this code base for a while and I just need to go back, start to look at it again.